All right, today we are cracking the code on two super powerful tools in math, the product and quotient rules for logarithms. Now, these aren't just some random formulas to memorize. Nope. They are elegant shortcuts that can turn some really messy problems into simple ones. So let's dive right in.
So let me start with a question for you. What if you could take a really complicated multiplication problem and, like magic, turn it into a simple addition problem? I mean, that sounds like a superpower, doesn't it? Well, that is exactly the power that logarithms give us. And you know, this isn't some newfangled trick. Historically, this was the entire reason logarithms were even invented. We're talking way before calculators. Their whole purpose was to take the massive headache out of huge multiplication and division problems. At their core, they're just a brilliant shortcut. Okay, so let's really dig into how this shortcut works, and more importantly, why it even exists in the first place.
It all goes back to something you probably already know, your good old exponent rules. Remember how when you multiply two numbers with the same base, you just add their exponents? Well, logarithms are basically the inverse of exponents, so it just makes sense that they'd follow a similar related pattern. They're really just two sides of the same coin.
And trust me, this is not just some abstract thing you do for fun. This shortcut is absolutely crucial for what comes next. If you're heading towards calculus, there's this technique called logarithmic differentiation that can take what looks like a nightmarish problem and turn it into just a few simple steps. Mastering these rules now is going to pay off big time later on. All right, so let's get our hands on the tools themselves. We're going to focus on two key rules today. First up, we've got the product rule. The idea here is actually pretty simple. If you see multiplication happening inside a single logarithm, you can break it apart into the addition of two separate logarithms. So, one log of a product becomes the sum of two logs. Simple as that. And right on its heels, we have the quotient rule. It's the perfect counterpart. This time, if you see division happening inside a single log, you can split it into the subtraction of two separate logs. See the pattern? An operation inside the log becomes a different operation between two logs on the outside. Okay, theory is one thing, but seeing these rules actually work is where they really click. Let's walk through a few examples and see how this all comes together. Let's start with a basic expansion. We have log base 3 of 9x. So what's happening inside that log? It's multiplication, right? 9 times x. That's our cue. We use the product rule. We split it into log base 3 of 9 plus log base 3 of x. But wait, don't stop there. We can actually simplify that first part. 3 to what power gets you 9? That's right, it's 2.
And there you have it, our fully expanded and simplified answer. 2 plus log base 3 of x. See what we did? We used the rule to break the problem into smaller, manageable pieces, and then we simplified the part we could. That is the core strategy right there.
Okay, let's try going in reverse. Now we want to condense 3 separate logs down into just one. The trick here is to just work from left to right like you're reading a sentence. First, we see log of x minus log of 5. Subtraction outside means division inside, so that becomes log of x over 5. Then we just bring down that plus log of y. Now we have addition, which means we get to multiply on the inside. And just like that, we've done it. We took those 3 separate logs, ran them through our rules, and packed them all into one neat, tidy logarithm. Our final condensed answer is log of the quantity xy over 5, from 3 logs down to 1. Perfect. All right, let's kick it up a notch with a more advanced problem. We need to estimate log base b of 3 over 16 using some given values. First move, that fraction inside the log is screaming quotient rule. So it becomes log base b of 3 minus log base b of 16. Now we're given a value for log base b of 3, but not for 16. But wait, 16 is just 2 times 2 times 2 times 2. So we can use the product rule over and over to say that log base b of 16 is just log base b of 2 plus another one and another and another. So now we just plug in the numbers we were given. We have 0.48 for the log of 3, and we're subtracting 4 of the 0.3s, which is 1.2. And boom, our final estimated answer is negative 0.72. This is a perfect example of how these rules let us figure out new things from the little pieces we already know. Now, these rules are awesome, but with great power comes, well, some really common mistakes. So let's talk about a couple of traps you absolutely want to avoid. This is the big one. You have to burn this into your brain. There is absolutely positively no rule for the logarithm of a sum. Log of x plus y cannot be simplified. It is so tempting to try and split it apart like you do with multiplication, but don't do it. It's a trap. Remember, addition inside a log is a dead end. And here's the other big mix-up. The correct rule is for division inside a single log. That becomes subtraction on the outside. The incorrect version, where you're dividing two totally separate logs, has nothing to do with the quotient rule. It's a completely different calculation. Don't mix them up.
So, why do we even care about all this stuff outside of a math test? Well, let's connect it to a really powerful real-world application. In fields like computer science, you often have to multiply a ton of really tiny probabilities together. For a computer, that's slow and can actually cause errors. So what do? They take the logarithm of all those probabilities, this idea is called log likelihood, so the computer can just add them instead of multiplying. And this quote just nails it. The very same rules we've been talking about. Let computers transform expensive multiplications into cheap additions. This makes a huge difference, speeding up everything from how we compress files to how machine learning works. It's that original shortcut we talked about, just supercharged for the digital age. Which kind of leaves us with a final thought, doesn't it? We've seen how logarithms are this amazing shortcut invented centuries ago that's still totally essential today. It really makes you wonder, what other incredible math shortcuts are out there, just hiding in plain sight, waiting to help us make sense of the world?